if you're tasked with going to the moon and you don't understand gravity, differential equations as the fuel burns and the weight of the ship changes, if you don't understand that there's less air at higher altitudes, if you don't understand that there's no moon on the, that there's no air on the moon, that's really a big problem. So you have to understand what it is that you're being asked to do in order to provide a solution that's viable. So statistically speaking, it is not uncommon for people to skip this. And by I say people, I don't mean the development teams or the architect teams. I'm talking about sometimes the management teams. They get requests from the customers and they don't understand what the customer's problems are. So they pass on to you the information as they understand it, and it just doesn't work well. So I don't know if you've ever seen the tree model where it shows the tree and what the customer asked for and what the architects designed and what the developers built. It's a very good representation of how many things can go wrong. So 14% of all IT projects fail. Never take these things personally. They fail because of a myriad of reasons. There's so many things that can go wrong. 31% didn't meet the goal. As I said in the beginning, you can have a really good solution to something that isn't your problem. 43% exceed their budgets. This is pretty common. And mainly that falls on the side of project management and the business teams, not having enough people, not understanding the problem, resources that, again, there's a thousand things that can go wrong. And 49% were late. If you move forward in the IT career, you are going to experience all four of these. And of course, the fifth one, which we don't show, which is success. You're going to have success and you're going to have failure. Just accept it. It's not personal. It's not you. Just keep your head up and keep rolling on. Projects fail for three very repetitive reasons. And those are communications, assumptions, and unrealistic expectations. John F. Kennedy, in the 60s, when he decided to go to the moon, he created what's called the BHAG. And that is an unrealistic expectation. It actually stands for big, hairy, audacious goal. It is something on the edge of undoable, but within the realms of doable. So you're going to come across a lot of that, and that falls into your 14% projects that fail. 14% that fail. It just is. Now, as a developer, you have the power to control one part of that, and that's communication. Your communication can either influence positively, or you can maintain the status quo of being out of the loop and not involved in the project. So what is code design? So we've talked about its failures without it. And code design doesn't necessarily mean that your project is going to fail. Code design is personal. It's just for you. It is to give you the ability to communicate with others, as you'll see later on in the deck, how important it is to understand the problem. I can't emphasize that enough. Understanding the problem is the key to solving the problem. So in its simplest form, it's merely a plan to provide or modify a service. Having a well thought out design allows you to share your ideas visually and easily, regardless to the level of your audience. Having a code design allows you to talk to your peers, to your buddies, and you'll see some of this later on of how simple this makes life. You can talk to your peers at work. You can talk to your buddies at school. You can talk to your management team, all with the same diagram, because it all says the same thing in a very clean, precise way. I know I'm repeating myself numerous times. It's intentional because I cannot emphasize the importance of understanding the problem. Einstein, he had 3 quotes. This is one of them. If I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about the solution. When you understand the problem, you understand the solution. So something that I was thinking about when I was putting this deck together is that code design may, for those of you that have been doing this for a while, you may see that it's a type of architecture, or is it software modeling? It's not. So it leads to those things, right? Architecture is a low level, very precise, very tight fitting document that outlines specifically what you're trying to do. Code design just says, hey, man, I think I know what's going on, and this is how I think I'm going to solve it. What do you guys think? So here are some basic rules for code design, and not just code design, but development in general. Accept that change is inevitable. Your first job, you're going to be told to the proverbial, move that pile of rocks over here. So you're going to move the pile of rocks, and then you're going to be told to move it back. That's going to happen because change always happens, because the business is growing, the needs are changing, the internet and the way things work today are so fast that not getting a product out quickly leads you to have to change due to a number of different reasons. Something that's very important that I find helpful to me is you have to remove a dependency on your hardware and software. You cannot design something for Windows or for Linux or for an iPhone or for an Android. You can write specifically for those things, but when you're thinking about the solution, you have to set those things aside and focus only on the problem and the solution. You want to design a solution to solve the problem. A lot of times you get caught up in doing something and you start seeing the coolness of what you're doing, and you really start feeling, you become enmeshed with it, and you're like, man, I get it. I know what we're doing. This is so cool. If I just added this and I just added this and I just added this, well, now you're the 49% of the projects that are late, because yes, your software is very cool. Yes, it's very adept, and yes, it's very forward thinking, but at the end of the day, it solved more than the problem. Something that the best developers in the world have mastered is being open to other people's ideas and input. When you take your solution to someone and you're like, hey, man, can you guys check this out? And they're like, man, I don't know what you were thinking, but this is not a good design. Don't give up on your own, how you feel. Don't give up on your design yet, but listen to what they say. Question them, ask them, why is that? What makes you think that? I know that this is the standard accepted model. This is the dogma of how problems are solved. And in our case, those would be your design patterns. But maybe you have a reason for not using a selected design pattern. Expect failures and setbacks. We touched on that earlier. Failing fast is the greatest part of software design that there is. In the old days when we had a waterfall, which you were given a specific target and a specific date to have that target completed, you did the whole thing, and then management came in and looked at it and they were like, oh my God, I'm going to fire you because this isn't what I asked for. If you fail fast, you're constantly telling people, hey, take a look at this, take a look at this. It's an agile model, but definitely expect failures and setbacks and don't let that disrupt you. Something that I see a lot of young developers do is they hear a problem and they say, Java would be great for this, or Python does this well, without having done a code design, without thinking about the problem, without understanding it. Python may be a great idea, except you need to run it on a phone, not really applicable. So don't be tied down to languages when you first start this. And of course, keep it simple, stupid. The KISS model for all things in life applies here. So what is design thinking? You can find this on the internet. It's not revolutionary. A lot of people don't apply it today because of the speed that people are expected to work. But let's talk about what the 5 steps of design thinking revolve around. To empathize or to understand. You want to take the time to fully understand the problem. What's the business impact? Who does it impact? Learn everything you can. I want to point you to the note at the bottom that this should apply far beyond your development skills. Anytime in life when you have these things, I have a test. Okay, well, let's empathize with the test. What do I need to do? What's going to be on the test? What chapters are we looking at? Are there any notes in class that the instructor said that we need to pay special attention to? So it's bigger than, it's a complete paradigm shift in the way you think. And it's very structured and it's very repetitive, and it allows you to build up some momentum as you age through your life. So define is step 2. Take everything that you've learned from the empathy stage and be capable of expressing exactly what problem you are solving and have a clear understanding of what done means. I cannot express to you enough. Understanding what done means is one of the biggest failures that young developers, it's the biggest trap young developers fall in. They feel that if I just solve the problem, I'm done. But others may not have that same opinion. They may need a backup plan or a contingency plan or a logging plan or a disaster recovery plan. You have to understand what done means. When I check my code into the repo, at this point in time, I know I have achieved done because it meets the criteria that's being set forth of me. And those things come from the empathize phase. When you're asking management, hey, exactly what are you wanting me to do? What deliverables are you looking for? Do you want a red box on a white background and that's all you want? Okay, I can do that. You just need to understand what it is done means. And at the same breath, knowing the problem is important. So ideate. This one starts the repetitive process in the agile model. So you have to come to terms with what it will take to solve the problems. You have to think outside of the box. Look at all of your opportunities, even ones that are unconventional, and then lay down your plan of action. So we're going to get into some of the box diagramming here in a second. And that is the part that you want to share your ideas with your peers and mentors. The ideate process is where you start thinking about, okay, I need to put a red box on a black background, on a white background. How would I approach that? What are the things I would do? And you just develop a path forward and you move on. So next, you don't ever want to hand someone something and say that it has met done until you've prototyped it. So when you start, you've written a little code. This is where you start slinging your code for the first time. So you make changes and improvements every time you iterate. Ideate, iterate, prototype, test. You're doing these things constantly. So your prototype, you start moving forward and you find out that red on white, for whatever reasons, causes certain problems on a given monitor at a different hertz. So you update your software to be cognizant of these things. And finally, when your prototype is working, when it's in a near polished state, you want to test it. And the test phase, it reveals the unknown. And we talk about that a little later in the positives of testing. So one of the things that you want to think about when you're developing software, as you start reaching that test phase, are the non-functional requirements. There are 7 of them. And they are things like maintainability, reliability, manageability. You want to think, okay, man, is this just some spaghetti code that I threw on my monitor and I got it done as fast as I can because I want to watch some football this afternoon? Or did you take the time to say, you know what, I've made this clean, I've made it precise, I've added some comments in here so that if I have to come back in the future, or if another developer has to come and look at this, they're going to have an idea of what's going on. Now, let's take this, this idea of code design, and I want to show you how simple it is and how powerful it is in its simplicity. So one way to tie all of these together, when I'm developing, I'll get on a call, I'll have the network team, I'll have the security team, I'll have the developers, I'll have a couple of my architects on, and I box diagram everything. I start with a clean page, I put it up there, and I start dragging boxes over. And I'm like, okay, here's this piece of software, here's this piece of software, here's this piece of software. And inevitably, once you get so far, someone pipes up and they say, hey, you know, where is the widget? I'm like, oh man, you mean we have a widget? So you have to put that in. And that goes back to just the iterative phase of going through all 5 of those steps repetitively, making sure that you understand the problem, making sure that you understand what people are asking of you. So when you're doing a box diagram, it gives you the opportunity to express your thoughts and ideas in a manner that can be easily understood by others without having to expose the full content of the problem. You don't need to share with people everything you know. You need to share what's relevant and pertinent for them to interact with you. You may give more information to developers, and you may give less information to senior management, and you may even give less information to your C-levels, to your executives. And that's because they don't really have time and they don't really care about the minutia down at the bottom. They just want to know, is the boat going to float? That's it. They don't care about anything else. They don't care what cool stuff you put in it. Your managers may care and your peers may care, but just target your audience. And the best part of this is a box diagram works for all of those levels. The same box diagrams I put in PowerPoints, just like this one, and share with the development team are the exact ones I put in high-level presentations to senior executives and CEOs, senior vice presidents. So it's very simple. As you can see, box diagramming allows you to tap into the prototyping phase without having to write any code. What I mean by that is you can lay out your code in a way, you can lay out your box diagram in a way that expresses what you plan to do in your code. You're kind of stepping over that line into modeling, but yet you're keeping it very simple so it stays on the box diagramming side. Communicating on this level allows you to demonstrate that you understand the problem. I have said this many times, understanding the problem is very important. And having other people understand that you understand the problem is important. In addition, it allows you to have a feel for what needs to be done and that you have a path forward. So I'm hoping that most of you on the here today understand how simple it is by the diagram that's laid out. That's a box diagram. It is literally that simple. If the house is on fire, pick up the phone, communicate with the fire department. So my problem is, what do I do if the house is on fire? And my solution is, to the executives, I'm going to call the fire department. To my managers, it's going to be, well, I'm going to find my phone and I'm going to make a phone call. To my development friends, it's going to be, well, I've programmed the number into my phone and it's under fire department, our house on fire. And I also have a means to text them. And there's a website that I can use. However you're going to communicate with them, those different levels of communication are still applicable to a single document. Okay, so here's a working example. And I do have software that we can take a look at in this as we move forward. So let's say that you're asked to implement a web-based solution that allows users to look up car owners by model. So the empathize phase, the first thing I would ask is, who is the end user? You know, is this customer support? Is it public users? Is it car dealers? What should the response look like? Will it be part of a system, or am I designing the whole system? Do I need to integrate this? Should I take into account the look and the feel and the motif of this software, or am I just going to be a widget on that diagram that someone calls and uses? How about the data? Where's this data stored? Is there a database? Where is it? How do I get access to it? Is this data private? Does it have phone numbers? Does it have credit cards, social security numbers in it? You know, maybe I don't want access to that data. And since it's web-based, should we consider that phone or tablet apps may want to use this solution as well? These are just questions you would want to ask up front to get as much information as you could. So we have the answers from the empathize phase, and we move to the define phase. We fully understand the problem, and we will understand what needs to be accomplished to consider the project done. So, and we recognize what steps are needed to achieve that goal. It's here that we ask such as access. Now we go to ideate. We understand the problem. We know what needs to be done. Now we need to map it out in a simple box diagram. We need to review the solution, ensure that it meets our understanding of done, share our diagram with our peers, and make sure that we're not missing simple things or overlooking technological limitations. This is very, very powerful when you're talking to your senior peers, because technology changes really fast. And big companies with T-Mobile, with Comcast, with NetScout, with these companies that I've worked with, they stay on the curl of the wave, maybe not the cutting edge, but they stay up with very modern technology. And as you advance technology forward, solutions that you learn here in high school, you may not be applicable when you get into the business world. So you just want to make sure that your peers that are pretty savvy, pretty sharp are going to tell you that, hey, there's a better way to do that. Or have you looked at the API for version X? Now that we have this done, our peers have said, hey, this is a pretty good design. I think what you have is going to work. It's going to meet this. It's going to meet kind of what the business wants. A quick question, a quick statement. When I say the business, there are two sides of a company. And in your case, the business would be the teachers. And the business would be your grades. There is a business side of a business who manages the business in terms of customer needs and business needs. And then there's the technology side, which just does the software, does all the heavy lifting. So when I talk about the business, I'm referring to people who bring the problems to you, because as an IT group, we don't define our own problems. We have to have someone tell us what needs to be done. So now we have this solution that we think is going to work. Now is the time we start slinging code. We're going to code, test, evaluate, code, test, evaluate, code, test, evaluate. That's the iterative process. I'm going to write some code. I'm going to test it, and I'm going to see if it meets the solution that I've defined for done and for solving the problem. Finally, we move into the test phase. And I'm smiling because it is one of the most frustrating phases of development. Your testing team will throw everything, including the kitchen sink and the neighbor's cat, at your software. And if you doubt me, wait until you get a good testing team. Well, they will take a text field and they will just hold the G key down for 15 minutes and then hit enter. It is crazy things like this that they do, and really good test teams will make you look like a rock star. You want the test team to find these problems, because the last thing you want to do is roll your stuff out, declare yourself king, put on your crown, and then have management come and say, man, your software is buggy and it's broke. And no one likes a broken crown. So your test team, although they may frustrate you and drive you absolutely insane, peer with them, understand that they're doing their job and that they're just there to help you out. So in our working example, we're going to continue this. Based on the information we gathered, this would be the box diagram of our solution. We've chosen to use a microservice implementation, and this is done so that sources other than web pages can fetch our data. As we noted, this may be a tablet. This may be a phone, or I don't know what else it may be. But next, we look at security needs. We know that that database may have private data in it, so we're going to keep it away from everyone. We're going to let our software talk to it, but we're not going to let the user have any access to it. We're going to control what goes in and what comes out. So let's segue just a little bit. I'm a security specialist, and I do a lot of work in cloud security. These are the kind of things that we look for. Cross-scripting is where you send a request and you overwrite what the page is going to do. These are things, this is where you take that into consideration. I don't expect younger guys to know that, but I'm sure you guys have heard all of these things before. If not, it does happen, and you do have to plan for it, and you do have to keep your data separated from the customer, and you need to minimize their ability to access it. And if you'll notice on the right, we have a legend. So we have a restricted network. That means that we're going to require a login. It's going to be firewall based. It has to come from a given IP or a given business or something of that nature. So by doing that, now you have two layers of security. You're protecting your data through the microservice. It's only going to do what it's asked and nothing more. And now you're also restricting it access-wise. If you're not familiar with what a microservice is, in the old days of writing software, you would have one program this big that did everything. So if you needed to make a change, you had to make a change in this huge, huge bundle of code. Imagine if you had to put air in your tires and you had to take the doors off and take the motor out to put air in the tires. That's an old way of doing it. A microservice way is just a microservice. It's a very small service. It does a single task. In this instance, it's going to look up some user data and pull back a car owner. From experience, we know that we're going to need a way to see the logs our software generates without having access to the system and compromise integrity. Again, that compromising integrity goes back to not being able to get into the system. Anywhere a user can get in, a criminal can get in. That's just the way it works. So if we limit the access to all of our systems, then we limit what can be done. So we've chosen an online logging solution. Here's a demo we're going to see, but before I go to the demo, are there any questions right now that anyone has? Okay, cool. Let's see, let's check out this demo. And you should be able to hit this from, let me share my desktop with you. This is what we're going to be pulling. It's called an Archangel project. It's something that I wrote at my time with T-Mobile. I use it to train our developers with Docker. This is a Docker thing, and I do a lot of training at T-Mobile for some advanced concepts. So let's take a look at this. So I have a server set up in the cloud that will pull this down, and let's go ahead and take a look at it. So this is the Archangel project. This is where it is. The instructions on building it are all available right here. So I think you've seen this model before, and it is this is literally the problem that we solved. And here is some of the block diagramming to develop our software. So I wanted the users to be able to build this software without having to understand what Docker was, without having to understand what Java was, or understand Maven or POM files or web apps or RESTful services, all of these cool things that you guys will learn as you progress forward in your careers. But I wanted to minimize that impact. So I wrote a small little bootstrap program that, as you see, if you pass it, it has 2 arguments, clean and start. And the cool thing about box diagramming is you make your own rules up. It's not like UML, the Unified Modeling Language, or Rational Rows that has a very strict set of rules that your diagram has to look like this. It has to be this perfect little box. Box diagramming is something I've come up with. I use it all the time, and it allows me to communicate on my terms. So here we have a bootstrap program. It has a clean and a start. So if I pass no arguments and I just run the default, it's going to seed the Mongo database. It's going to put the car data into the database. Then it's going to build the container. The container is a Java image that is a pre-built box that has everything it needs inside of it. Next, we're going to build the UI. We're going to build a microservice, and then we're going to go ahead and pull down the Dozzle image so that it's on our server when we get ready to start it. If we passed in the argument to clean, we're going to remove the existing images as they progress forward. And if we also pass in the start argument, at the end of the cleaning, seeding, building, compiling, putting everything together, we're actually going to go ahead and start it. So I have a little script here that will check the code out for me. I'll let you guys see what that is. It does a git clone of this piece right here, you probably won't be able to use this one. You'll have to use the HTTP, which would be this one, HTTPS, because this won't ask for a password if you pull the code down this way. So next, let's just go to that folder and do an ls. So here's your basic software structure. And you know what, before I get into this, are there any questions about the code design and thinking that way or anything like that? If not, we'll go ahead and continue with kind of the demo phase of this. All right, great. So this is our Bootstrap, and let's go ahead and look at it. It is very simple. It just is a single shell script, and this won't run on Windows. I tell you what, I will add a Windows Bootstrap command right after this meeting. So if anyone checks it out and wants it to run on Windows, you can. You're going to need some of the technologies that come with this, and I've added those here. For diagramming, I use Glyphy. There's a great Chrome app. I can actually show that to you right here. It's a very cool app. It's free. And if we were to open something, let's open up the diagrams that we did yesterday. Here are the diagrams that we did. Just simple block diagrams. You have a bunch of different shapes. You can do swim lanes. Here's actually UML, the very restricted cardinality pieces. You have network diagrams, site maps, basic images. You drag these over, like that's how these images got in here. So this is a great tool, super simple. It's free, and there's a Chrome plugin, which I just demoed for you. And okay. So what we're going to do is we just checked the code out. So we're just going to execute the Bootstrap. It's downloading the Docker image. These are things that aren't in, let's set that over here. These are the pieces that don't go in your box diagram, because your box diagram is more of a big picture. It allows you to say, hey, can I do this? What do you think? Because let's say that let's actually look at this in a realistic, let's actually go back over here and grab this. What might happen if you presented this diagram to one of your peers, or say your management team, they may come to you and go, you know, since this is web-based, what do you say that we have a microservice on here? We add a line for a phone or a tablet instead of just a web page. Those are just more pieces of where the code comes in. But this is a very big picture. We're not looking at small details. That does get into your modeling. That does get into architecture. We're just trying to keep it high level. We're trying to solve a problem. So our Docker images are building, and it looks like it's building the software as we have it. These are all Java RESTful services. Okay, so now we can go ahead and start it. And now it's running. So let's. You can actually see the software here. So let's say you're going to search for a user with a compass. You click on search, and it comes back with your data. You notice that this comes back with a very ugly JSON block. I don't think that my understanding of what done would have been what the business had in mind. Yes, it works. Yes, it does look up a user by car model. It does return the information, but you see, I'm only getting one result at a time. Surely more people own a car than just one. This falls into, did I understand the problem? Did I understand the definition of done? Apparently, I would say I probably didn't. It's here for a reason, for that very reason. So yes, it does do what it wants. I can look up people by car model, but the data isn't informed. It doesn't help a user do anything. I don't appear to be showing any kind of data. I don't appear to be showing any kind of private data, but yet I have put in, the user where this user lives. So not really a good design. So I think maybe I need to go back and work on this again. But let's say that things didn't work. Let's say that it started to fail, that it wasn't living up to expectations. How could I find that? So this is where we go to our logging. Here is our log tool. Here's our database. You're not going to see much here, that your connections are opening, they're closing. It's looking up the driver. It's telling you a little bit of information. Here's our microservice. So as the cars come in, we see what's coming in, and we can actually do this in real time. So let's go here to Edge and watch down here at the bottom. It's going to trigger. There you go. It just came back in. Here's the gentleman's city. And here's the car model in Edge. Okay, so this seems to be working well, but what if we weren't getting to this point? So we would have to look in the UI. Here are the logs, here are the UI logs. So these are telling us that we're setting the URL to this value. You can't hit this value because this is all of the Docker network. It's all private. It matches exactly what we have here. These black lines, that's what our software is doing. It's talking to the microservice right here on the private network. It's secured. We can see it because we're the developer. And if you notice that it's a red line coming to Dazzle, it's open to the public today. But in a real setting, that would be locked to my IP. Not really beneficial when I'm trying to do a presentation. So we see that we captured the value edge. We set the URL. We passed the query. And the microservice told us that it received it. And then it responded to us with this value. This debugging is very important for the testing phase, because let's say that we had put this out there and the test team comes back and they're like, hey, I keep putting in Edge and it keeps coming back with Compass. This is how we go and troubleshoot that, because we're thinking ahead. We have a box diagram. You can pass this on. You can pass this diagram to the QA team. The QA team is your test team, quality and assurance, and say, hey, this is where I'm at. Where do you think this problem is happening at? Most of the test team are developers. They're just doing a job in testing. So, and if they're a DevOps team, they will likely fix your code for you. Don't always count on that, but that can happen in certain teams. So this is the basic product, the basic breakdown, and we can actually, remember we were talking about using it if a phone were to use it or a tablet. We have a way of testing that as well. That would be this red line right here. We're fixing to test. There's no way to get directly to this microservice from outside. So we're going to have to use another tool to get there. We're going to use a testing tool. And we're going to go ahead and close some of these pages. We're going to open up our test. And as you see down here, let me explain this a little bit so you guys can see this. We're actually going to call CI/CD Mojo Live 8888, 8880, which is the request. And we have a JSON value. And that value, we will do a post, and we're going to run it. Here's our test data. We're passing in car model compass, because when we go back to our logging, when we go back here, we see that that's how we're passing the data in to the microservice. It's receiving the incoming JSON data is car model and edge, or edge, or the other versions. We're just seeing that this is the formatting of it. So we have car model and compass. So we're going to run that. We're going to do a post and we get the data back. So now we've tested the response from the server. Again, this falls into our we should be doing this in the prototyping phase because we want to make sure that our stuff works. And, you know, that concludes everything. I think I put all of this in, all of the software that I use to design and build this stuff, I believe is right here. SOAP UI, it's all open source. It's free as long as you're not using it for commercial use, meaning as long as you're not making money off of it. Everything is out there. It's free. All of my software is licensed under the open source stuff. You can feel free to look around on my GitHub account and use any software that's out there. There's a ton of stuff out there. There's a lot of cutting edge Docker stuff and some advanced stuff out there. So this brings us to the last slide. And are there any questions? You guys have any questions? Cool, you're welcome. I hope this does help you guys out. Having a plan to share something with others is definitely a benefit when you're just learning the business. I will. You know what? I will actually put this deck on my GitHub account. Let me grab this. There you go. Right. And flowcharts are a little different. Flowcharts are more of the modeling phase, still very powerful. You know, I'm a software architect, and that's what I've been almost all of my career. So I cannot express to you learning UML, learning flowcharts, learning how to communicate through diagramming is just powerful. And I get more joy out of doing architecture than I do writing software, but I still write software for myself. But yeah, flowcharts are great. So here's my way of thinking about all the new technologies. Is there a way to manage it? Why don't you do a box chart? I mean, that's where I would start. I would start right here with good old Glyphy. And I would put, let's do this. Let's do it in real time. So I want to learn Java. I want to learn Python. And I want to learn Git. I want to learn MySQL. MongoDB. I encourage everyone to take the time and to learn MongoDB because it's free, it's powerful, it is outstanding. I worked for a startup company in Dallas, and we were worldwide. And when the soccer games, I forget what they're called, the World Cup, I believe is what soccer is called. When the World Cup would be going on in a country, we would spin up 3 or 4 more of these Mongo servers to do our data, and we would link them to our main servers, and they handle all the traffic. They are geolocation routable, geo meaning location. So that's something I would do. I would definitely learn. This is NoSQL, by the way. This doesn't belong over here. This is called NoSQL because it doesn't use traditional SQL means select from, where, and the group bys. But MySQL, and I would also learn a little Postgres. These are pretty good right here. This is a great place to start. I would also highly encourage you to learn Docker. I would encourage you to learn Git. And before you do any of these, I would learn these first. So Docker is a technology, and Git is a technology that persists your code. So when you look at GitHub, this is my software. So I have different branches. I have different things that I do with it. You can see I have JUnit. I have develop. I have Fargate. Fargate is a technology that AWS uses, which means there's no server. It's serverless. You spin this up and you spit it out. Old Master, I backed that up for Virtual Code Day because there were some things in there that needed to be taken out that didn't really apply to this. SonarQube is a testing tool that will scan your code and tell you if you have a lot of bugs or anything. Highly, again, I urge you guys to get into all of this stuff. And then I just have a test branch where I'll do a bunch of testing and I'll be trying some crazy things like, well, I don't know what I try. It's crazy. And then you push all these branches together. So you do a pull request and you're going to bump JUnit and you open the pull request and then it merges the code together. Very powerful. Docker, on the other hand, is phenomenal. If you look at this on a single server, all of these services are running under Docker. We have the Archangel UI, the microservice, and Dazzle. We have Mongo. So these pieces are pretty powerful when it comes to that. So on our little Gliffy diagram, to the person asking that Q&A question, I would definitely start with learning some of these technologies because these technologies will allow you to run Java. Let me give you an example. Let's do Docker run. I'm going to remove it. We're not going to put any ports on it. We're just going to run Java 8. So right now on this thing, I just started an instance so that I can run Java. Oh boy. There we go. So Java 1.8. It's 1.1, so it doesn't support the new multi-threading, which is in the 200s. So I can exit out of that. How about Python 3? Okay, so it's pulling down a Docker image that runs Python. Gitflow. Gitflow is very cool. I would put it down here at the bottom because it marries a lot of this cool stuff together. And Gitflow actually comes from GitLab. You can do the same thing for MySQL and Postgres. You just, I'm going to stop here, but you can pull these down. Just go to Docker Hub. Docker.com, and you can start using this stuff. They're all free. Now, they do come with licensing, but you can download and run them anywhere. I would start here with Docker to the gentleman that asked the question. All right, a couple more QA questions. Okay, that's a good question. What I would recommend there is find a problem and then solve it. I want my mom to be able, or my dad, or my parents, to be able to create a grocery list. And that's where I would start. I would just start building software. But if you don't have a problem that you're trying to solve, all you're going to do is flutter around and you're never going to get anywhere. So box diagramming allows you to see the problem in your mind, put it down on a piece of paper, and understand what you're doing. So here were our Java. So let's do this right here. I thought, yep, there it is. So here's your UI. Here are your services. Here's your database and your printer. So you could have a UI that talks to its services, or you know what, you can make it really simple, because I believe you're asking, how do you prep for that? So just create a UI and a database. And now your mom can print out some of these things. What's really cool about this is these can both be Docker containers. So you can download Tomcat, and I would just find how to answer that question. Create a problem and find a solution. Maybe you want to use Python. Maybe you want to use Java. I recommend Java. I'm a big Java guy. And just get out there and work on it. You don't need a lot of technology to make these things happen. And find a good editor. I do recommend Eclipse. And always look at open source tools. People will lead you to buy things, but as a college student and as a high school student, you are entitled to a plethora of free solutions because it's an educational purposes. So I hope that answers your questions, guys, girls. Okay. No problem. Thanks, guys. I'm out there on GitHub. If you ever want to just ping me out there, you can find me on LinkedIn, shoot me an email. I'm available to, if you have any questions or anything, I'd be happy to help you guys out. Okay, enjoy the rest of your code day, and man, just stay positive. Bye, guys. Take care.